I have no idea how much room I have on there.
Oh, Jesus. We also do. Okay, let's see. So quick little view, let me see. Can somebody tell me what type of shape that would be if you graphed it without doing any work? Yeah, why would it be elliptical?
Divided by 36.
Yes. So the coefficients of the x squared, y squared are different. So it's going to act differently along the x and the y direction. It's kind of a really cool idea if you think about it. Is this in the right form? What do I have to do to put it in the right form? Yeah, I need a 1 over here, right? So whatever this is, I divide by it to make it 1. So the x squared over 4, y squared over 9. Now, you have two levels of this. It's almost too simple to believe. Ellipses. And sometimes it's hard to remember why it works the way it does. But these are two positive numbers, right? We are not dealing with complex numbers, thank God. You don't even want to know what the graph paper would look like. It wouldn't be any graph paper. So let's just stick with real numbers, not complex, imaginary business. These are two positive numbers then, correct? Okay. And they add to be 1. So what is the biggest that either one of them could ever be? This number and this number add to be 1. What's the biggest that either one could ever be? I love you guys so much. They're both positive. Could either one of them be 2? If they're both positive and they add to be 1, could one of them be 2? 2 plus what positive thing is 1? Ain't no such shit, right? So if they're both positive and they add to be 1, what's the biggest number that either one of them can be? 1. If one of them is 1, what's the other one? 0, and 1 plus 0 is 1. It's crazy. Oh my gosh. Come on now. Come on. Come on. Okay. Well, you gotta make it all hard, Jeff. You just put the 2. No, you gotta kind of know why it works the way it does. That'll make it stick in your head better. So, therefore, what makes this 1 if x is 2 or negative 2? You guys, is that cool? Because you're saying, what do I square to make this? And that's why the shortcut is, you look at the square root of the bottoms. Why is that shortcut work? Because of everything I just said. So how far out in the x direction am I going to go? What's the center?
0.
Yeah, it's not been shifted anywhere, right? There's no x minus or x plus or y minus, y plus. It's not been shifted anywhere, so it's going to be 0, 0. How far out in the x direction am I going to go?
2.
Yeah, why is that?
Square.
Alright, so just like we just said. Now somebody besides this row here, how far out in the y direction am I going to go? 3. I love it. So the square root of 4 is 2, and that's with the x. So I'm going to go up and down 2. And the square root of 9 is 3. It's with the y, so I'm going to go 3 there, in the y direction, and then connect. And my scale's all funky, but too bad for me. My time's that up. Saw some debate. It should be longer this way, but my scales are all freaky. So if I wanted to change one thing to make this equation a circle, what would I change? Just change one thing. what would make this a circle? Why is this not a circle? Those two numbers are... No. Circles require squares, for damn sure. That sounds so funny, doesn't it? I mean, circles need squares. No, circles need squared pieces in it. Right? If only one thing is squared, it's parabolic. If neither of them is squared, it's a line. They both got to be squared to be a circle. Yeah, like it? So what one thing could I change in the original equation to make it become a circle? Why is it not a circle? These two numbers are different. So what's one thing I could do to make it a circle? Make those two numbers the same. So if I could only change one thing, maybe it could make the 9 become a 4. So let's write that. Let's see. So if I had 4x squared plus 4y squared equals 36. Now, to be completely honest, I could look at circles as ellipses, because circles are just special ellipses, right? They are ellipses that go the same distance out, x and y. But how do we normally look at the equation? How do I put this into the right form for a circle? You divide by 4. Because now what can I see? Yeah, what's the radius of the circle? You can't stop yourself. And the radius is 3. And the center, of course, is 0, 0. I like it. So then I'll start at 0, 0, and I go up and down. 3, and left and right. 3, bam, bam, bam. All right, so circle's nice. We know, make a circle, sort of. Okay. Now, real quick, I swear to God, hopefully you guys can follow along. Never do what I'm about to do, but I'm going to do it anyway. If I divide it instead by 36, when this become x squared over 9 plus y squared over 9 equals 1? That looks like an ellipse. Don't even write that down. Doesn't that look like an ellipse? How far in the x direction do I go? 3. And the y? 3. That's a freak. There you go. It's just, why do I put it in this form then? Because we have developed a thing called the radius, which describes how far I go out no matter what I'm looking at, because it's symmetric. The x squared and the y squared have the same number. So I can call it one thing instead of two different things. This has got 2 lengths. This has only got 1 length. So why not put it all together? Okay, maybe. So the main difference between an ellipse and a circle is that the coefficients are different of the x and y squared. They both have a plus. Now let me see if you guys can get this. This is related to that thing earlier that was a lot of fun, about 2 things adding to be 1. Just to kind of get us into the next section. If I have 2 numbers, let's say I have 2 numbers that add to be 10. Give me 2 numbers that add to be 10. 5 and 5, that's awesome. Give me another. 8 and who? 2. All right, that's them said 8 and 7. I was worried. Right, adds to be 10. How about 10 and 0? All right, now let me put the extra thing in. And then 11 and negative 1 would work, because I haven't said this yet, but they have to be positive, let's say. If they have to be positive, then the most either one could be is 10. Just like we talked about earlier. What if I have instead, so if I have like x squared plus y squared equals 10. Whoa, there you are. Then the biggest either one of these things could be is 10. That's why the graph of a circle or an ellipse is contained. There's a certain maximum amount that either one of them can be. It's contained. What we're about to do is draw the graph of something that's pretty much the opposite. It's the hyperbola. There's uncontained. It just goes crazy. If I told you 2 positive numbers have a difference of 10, is there any biggest number that either one can be? If x squared was 100, what's y squared got to be? 90. If x squared was 1,000, what's y squared got to be? 990. Do you see how it's uncontained? Do you see how crazy-ass Jeff goes beyond just, you're trying to draw the shit. Think about, it's subtracting. That's why it's allowed to go, it's allowed to just go to infinity. It's not contained. Goes like that. Goes to infinity. I like it. There's a certain minimum that it could be. Could x squared be 9? Can I take 9 minus a positive number and make it 10? No. So there's a certain minimum it could be, and then from there it can go out. You can go crazy. I'm drawing the thing how it's going to look, but we'll see why in a little bit. Okay. Whew. All right. So let me give you this next little handout. Oh shit. This is from section, shoot, let me give it to you this other way. Please don't freak out. There's one side that's 14.1, the other side is 13.3. We should probably start with 13.3. Hyperbola. Let me see if you guys get this. Now let's see. Look at this bad boy right there. Okay. Which variable, don't say anything out loud yet, which variable cannot have a value of 0? Don't say anything out loud. Which, can I not put a 0 in for x, or can I not put a 0 in for y? Just think about it for a second. Is there a certain variable, or can I put 0 in for both? Maybe I'm just tricking you. Haha. All right. So which one? What do you think? Is there one of these variables I cannot make 0? I can't plug 0 in for. Which one? A and B. Okay, let me try again. A and B are numbers like 4 and 9. Do you see how they're exactly like this from earlier? Right? A here is 2, B here is 3. That's A squared and B squared. So A and B aren't really variables. They're numbers that they're going to give me. X and Y are the variables. So is there X or Y? Can I not plug 0 in for one of those, or are they both okay at 0? If I try to plug a 0 in for X, if I try to plug a 0 in for X, is that possible? This says negative positive number divided by positive number equals positive 1. Well, positive divided by positive with a negative out front is going to be a negative number. Is there any way it can equal 1? Ain't no way in hell. Now, what do you find? What do you find when you make a variable? Oh shit! What do you find when you make a variable equal to 0? What is it you're trying to find? Come back.
Like ally.
Trying. Oh well. It's going to make this class very difficult to teach. Yes?
Oh, lights out mean I can sleep now?
You can try. Alright. I'll throw something at you. Alright, let's try to start over. Now let me ask this again, while this thing is hopefully warming up. When you plug a 0 in for x, what is it that you're finding? The what? The y. Oh, I love you guys. I think somebody said it. When you plug a 0 in for x, you find the y-intercept. To find the x-intercept, you put y equals 0, right? So, when you put a 0 in for that, everybody's got that sheet anyway. When you put a 0 in for x squared, you get negative something over something equals 1. There's no way. Okay, so what does that mean? There's no y-intercept. So the short thing to realize there then is it cannot go through the y-axis when this x squared something minus y squared something. So what ends up happening is it's got an x-intercept, so it sits on the x-axis. So that's why it says on that sheet, let me try that. That's why it says on the sheet, along the x-axis underneath there. Now look at the next one. What's the positive variable term in the next one? The y squared over b squared minus x squared over a squared. Then the y is the positive one. So in that case, it has no x-intercept. Reboot the system like in transfer. Less limb injuries. Oh, okay. Wake Sean up. Sean, wait. Okay.
Alright.
So this one is going to be along the x-axis. This one's going to end up looking like I keep tracing in the air. It's going to have x-intercepts, but instead of being closed like an ellipse, it's going to open the other way. They just never come together. They don't come together. So if one is plus and it goes this way, and the other one's minus, it's going to open away from each other. It never kind of comes together. It just goes forever off looking for, oh, where's this other half? It's never going to find it. It's looking the wrong way. It's a very sad tale. Never realized till now how sad hyperbolas are. This guy, it's not going to have any x-intercepts because I can't make y 0. Therefore, it's going to open like this. Woohoo! Okay, I like it. It's always looked like a coat rack to me. All right. Now, let's not worry too much about this. I want you guys to realize this is kind of beautiful, to be honest. Let's just do a problem. That's really the only way to really get this. Now look at this guy. It's going to start off just like ellipses, but I'm not going to connect them. I'm going to make them open the other way. But still, how far out on the x-axis will I go? 2. Definitely. Bless you. And which one of these does it look like? The first one or the second one?
The first one.
Yeah, the first one, because x squared is the positive one. I like it. So it sits on the axis that relates to the positive part. That's too beautiful. Again, why does it do that? Because of all the stuff we talked about earlier about intercepts. That's why it does that. Okay. So at 2 and negative 2, there are vertices. Now, I can still go out on the y direction. It's still going to be useful for something, but I'm not going to put points there. There are no y-intercepts. So how much am I going to go on the y-axis? 3. 1, 2, 3. Put a little x there. 1, 2, 3. Put a little x there. So if this was a plus, I really want this. This is kind of cool. Please let this be a little tiny bit cool. It's like this much. If there was a plus right there, I would just draw an ellipse and be done with it. But now instead of this connecting with this, it's going to open the other way and just sort of never connect to anybody. Aww. And this one's going to open this way and just always look for, aww. Like I said, I can't do my homework, Jeff. It's too sad. But what I can do, here's what's really, let this be. I can draw that I'm going to just draw this. You guys see what I'm doing here? I'm just drawing this little dotted box here, a little rectangle. Little rectangle. It goes out this much as far as I'm allowed to go, and it goes up and down as far as I'm allowed to go. You can always make this little box, and this is almost too good to believe. Now, through the corners, I'm going to draw what are going to be asymptotes for this. So through the corners, try to draw them better than me. I'll do this job. There, not too bad. All right, now this is new. This is new, but it's not difficult. So now it's going to do like this. It's going to open and start to follow this, just like an asymptote. It's going to do like an asymptote. It's going to open and follow this. Just like an asymptote. Now, if this would have been turned around, if these would have been turned differently, if the y squared part was positive, it would have been up here. Do you guys see that? It would have been here and there. If I would have made this negative and this positive, it would have just been here and there. All the other shit I did would have been exactly the same. My little box would be in the same place. These would be here, though, the vertices. They would be real points, and then we would just go up and down instead of left and right. All right, so see how far you can get on the second one. You guys try the second one. Yes, Jeff, I know. There's number 2 yet. We know. Now, if you go to pre-calculus, you will get a little deeper into some of the stuff we're talking about with parabolas, circles, ellipses, hyperbolas. You will get deeper into them. This is just introductory level stuff. Right? So let's see, how far do I go out? Now, first off, which one is going to look like?
Second one.
Second one, the coat rack. I like it. Why? Because the y is positive. It's crazy. It's awesome. Too good to believe. How far out in the y direction do I go? Well, 5. Center is 0, 0, which I'm going to tend to gravitate towards because this is just the introductory of this. So I'm going to start at 0, 0. It could be shifted, and I'll just start there and start counting the same way. But start at 0, 0. I'm going to go 5 up, 1, 5. I'm going to put an actual point there, right? Because it's the coat rack. And there, 5. How far do I go in the x direction? 4. So, and I can put a little x there. And I can put a little x there. Or just something, not a dot, because it's not a point on the graph. And you make your little guiding rectangle. I love that. This is your spirit rectangle. behind you. Sorry, you didn't get to smoke it. You didn't have a journey. Okay, and then I can do my... Sometimes you just read me. And then I can do my asymptotes going through the corners. Now, there's a lot kind of packed into why those asymptotes are asymptotes. And they have to do with something called the limit. If I let one of these variables get really, really big, it starts to approach that line. All right, so again, you're going to talk a lot more about that in the pre-calc course if you do take pre-calc. If you don't, you just got to do this, what we're doing. So we can draw through the corner. Scheisse. Alright. Make sure those are dotted lines. Again, since this y squared, it's going to be up here and down there, so it's going to open another really fat one. Poor little dude, I'm sorry. So, if it would have been x squared first, it would have been like this. Would have been here and there. Same way that one was. So those are the two types of hyperbolas that we can see. Does that look like what you guys got? Okay. Do these real quick. I love this kind of question. Notice it doesn't say anything about graphing them. There's not enough space anyway, so don't do that. By the way, I will be giving out practice final today and tomorrow in the labs, I think. Just because I'm tired of people not coming to the lab. So if you want one, you better come to the lab. And then I'll have an answer key for that on Thursday. Our final is next Tuesday, if I remember correctly. And I think it starts at, I don't even want to say. Shit, what time does it start? What do I got that? 9:25? I have a little list. I don't.
Yeah, from 9:25 to 11:25.
Yeah, I put it up on the syllabus and the homework sheet, both. So just realize that. It's kind of nice it starts after we normally start, so they don't get people coming in like an hour and a half late and going, I didn't realize it. This way, if you come on time, you're early. That's awesome. Okay. For those of you that don't pay much attention, you'll be saved in this case. This should be relatively quick if you get it. This one, how many things are squared? Just one variable has a square on it, so therefore it cannot be a circle or an ellipse. So this has got to be the only other option. So parabola. Can anybody tell me, it's not a part of the question, but can anyone tell me, is it going to open up and down, up or down, left or right? It's going to open sideways, I like it. And in this case, it's going to open right because this is positive. This is x equals y squared, which is the opposite of y equals x squared. So it's not going to do this, it's going to do this. What about number 4? Tier. Alright. We know it's not a circle. Now, to be honest, we also know it's not an ellipse because both a circle and an ellipse require what between the squared things? A plus. This is minus. So, what is it then? Hyperbola, yeah. Hyperbola, if you want to say it correctly. Don't listen to me about hyperbola. It's a hyperbola. You get a parabola, one of them goes away, the other one gets all hyper. So does everybody see that? If that was a plus sign, then it would be ellipse because the coefficients are different. Hyperbolas don't really give a shit if the coefficients are different. They just, it's a minus, we go like that, we get away from each other. What about number 5, though? Yeah, why is it a circle? Are your x squared and y squared together? So the first thing is to add that over. And of course, it's not an ellipse because these numbers are the same. So it is a circle. And you could divide by 5 and figure out what the radius is, but you didn't have to. So this is a circle, and I'll bet you anything. If you add the y squared over, they have different coefficients, and it's plus. So this is completely an ellipse. I love it. I love it. Say again? Oh, shit. No. That's number 3, 4, 5, 6. Yeah. It's not 6.4. Oof. I want to do that too. Okay. Ooh, I like it. A little bit of time. Okay. So we're not going to do section 13.4 out of chapter 13, just because I don't want to. So circles and parabolas, 13.1. And then we have ellipses in 13.2 and hyperbolas in 13.3. You do have to know how to graph each one. Ellipses and hyperbolas have the same first step. That's too beautiful to believe. And if you look back at what we did here, if that was a plus, it would just be here. Right? Since it's a minus, it doesn't come in, it goes out. That's so nice. Okay. Let's take a step back in time. This should sound very familiar to you. Before I turn the page here, can somebody tell me what the next number will be? I'm going to let you think about it for a minute. Don't say anything out loud yet. So you remember these kind of problems? Yeah. Predict the next term in the sequence. So what do you start thinking about? Did I just keep adding the same number? No. That would have been easy if I was, and of course I didn't because I'm a dork. Yeah. Then you say, so one of the first things you look for is the difference between two things the same? Meaning I kept adding the same thing? No. The next thing you should probably look for is, well, did I multiply by something over and over? So what my intention was, is that I multiply by 3. And sure enough, if you check it, multiply by 3 again. So then the next number would be what? 54. I like it. Now sometimes, if I don't give enough of these, you could find multiple sequences that work. And that's what these are called, sequences. You could find multiple things that work. If I would have just put 2 and 6, what's the next number? Well, I could get a lot of different answers. And most of them would be valid. Maybe I added 4, so what would the next term be? 10. Of course, I go, well, that's not what I meant. But if I don't put enough down and your answer still works, you get full credit. I'm not going to be like, you got to figure it out and you got to know which one I'm in. It's bullshit. Sometimes I'll write it and I won't even realize there's another way to look at it, and I'll grade and I'll go, holy shit, that works too. No way. You won't get bonus credit though. Don't get too excited. All right, well, what about this one, of course? If I had 1, 7, 13, what do you guys think? Yeah, what do I keep doing? I keep adding 6. So then that could be 19. What about this one? All right, get ready. The next two are going to be freaky. I'll tell you that right off the bat. So I can do this in my head. All right. Some of you guys might know that one. I'll let you think about it. For what? This one?
Yeah.
Why?
Because of the odd number.
Oh, okay. Yeah, that works. I think you're saying, so here I added 3, here I add 5, here I add 7, and then 9. That's not the way I thought about it, but I'm going to get the same number you did because of a very interesting thing about squares. Did somebody else get something, another way to look at it? Or you're all sitting there like, just tell me, shit. One of those little bonus flipping questions. Think about 1, 4, 9, 16. What are those? Squares. And see how I just added 1 to each one? So it'd be like, let me see if you guys get this. It'd be like n squared plus 1. That's the way I was thinking about it. Now notice something about squares. All right, before we do this one, I want you guys to see something really interesting about squares. This is 3, this is 5, this is 7, this is 9. Cool, right? And do you notice, let me see, I don't want to say this. Alright, I'm not going to worry about it. It's a really cool, have you guys ever seen that before? Have you ever noticed that before? So, what's interesting is, now watch. What's the square root of 16? 4. What's the square root of 25? 5. 4 plus 5 is 9. Right? Alright, now watch. So let's go ahead a bit. 121 is 11 squared. 144 is 12 squared. What did I add to get from here to here? What did I add to get from here to 23, right? And that's 11 plus 12. So now I'm going to add 12 plus 13. 12 plus 13 is 25. 169, which is 13 squared. All right. I know some of you guys are just out there going, my flipping God, what the shit does this guy do? He's playing with numbers. The shit. But so hopefully some of you guys are like, okay, I see. You can actually use this to do squares in your head real quick based on squares you know. We invented calculators. Oh, shit, whatever. I always got somebody who's thinking that. So let's flip this over. We're just going to do the first bit of this. You guys try these first 3. Oh, I forgot to do the other sequence shit. I'll do it in a minute. Oh.
I already solved 1 and 2.
Sweet. Sorry. That is good, Sean. Yeah, the first one we just saw that. That's pretty straightforward, right? Oh, here's this one. Obviously, what's the next 3 in this one?
36.
Yeah, 6 squared, 7 squared, 8 squared. Right? That's the next 3. What about this guy? I just keep adding 3. So the next 3 are 8, 10. What about this one? So this is an example. One way you can look at this. You can look at this as if it had 2 separate sequences in it. Now you can also just go add 5, make it negative. Right? Just so you can flip 5, 10, 15, 20, 25, and every other one is negative. So that's a very simple way to look at it. Or you can go 5 plus 10 is 15, plus 10 is 25. Negative 10 minus 10 is negative 20, minus 10 is negative 30. Minus 10 is negative 40. And the middle one would be 5, 15, 25, 35. But look, a better way to look at it is 5, 10, 15, 20, 25, 30, 35, 40, where every other one is negative. It's kind of a different approach to making a sequence. Now, to be honest, the sequence could have a lot of layers to it. It's crazy. And you can have a sequence that's not even related to math. Let me see you guys. What about this one? I love this sequence. DRMF. And I always have, when I put this as a bonus question, I have people that write out the alphabet and put numbers next to them and try to start figuring out. No, it has nothing to do with numbers. It has everything to do with, want a hint? It has everything to do with music. Have you ever seen The Sound of Music? Something dear. I go do a Homer Simpson. Ray the Captain Ghostbuster. Me, it's all about me. So do, re, mi, fa, so, la, ti, do. All right. I love you guys. I'm not going to put one like that as a regular problem because that's just kind of like, is it come to you or not? I'll put the planets. I'll put OTT 1, 2, 3. Right. All right.
If you're going to give us anything related to music, no way, I'm running away.
It would be a bonus question if I did. Real quick, last thing. Have you ever seen this sequence before, except for the time I put it up here a minute ago? Maybe? Well, you know, I've been on this earth for a while, so I've seen a lot of shit. 1 plus 1 is 2. 1 plus 2 is 2 plus 3 is 5. 3 plus 5 is 8. So what's the next one? 13, and so forth. This is called the Fibonacci sequence. It's related to what we find aesthetically pleasing as humans. It's been proven. If you take two frequencies that are in this sequence and combine them, you get a pleasing sound. If you take two that are completely not in the sequence and combine them, that's the sound that wakes you up in the morning. Right? So I love this. This Fibonacci sequence is a huge thing between the intersection between math, art, music, biology, finances. A friend of mine used Fibonacci to make money in the stock market during the recession. It had to do with the number of times there was up and down movements. It predicted when there's going to be a big down or a big up. It's incredibly crazy. All right, enough.
Too much fun today.
Yeah.